Questions are fine. Don't worry about the fact that I'm recording. State whether each sentence is true or false. If it's false, replace the underlined word or phrase to make it true. Do you know what this is saying? If a parallelogram is a rectangle, then the diagonals are congruent. Is that a true statement? If you do not know immediately right now that that's true, you've got some serious studying to do. Okay, that is true. Diagonals of a rectangle are congruent. You need to know that. It should be something you know, else you're not going to know how to do several of the problems. All right, so that one's true. Now, the next one's a little bit more confusing in its wording. A midsegment of a trapezoid. All right, so maybe you better think about what is a midsegment of a trapezoid. A midsegment of a trapezoid connects the midpoints of the trapezoid, of their legs of the trapezoid. That's a midsegment. Is that a segment that connects any two non-consecutive vertices? Is it connecting any vertices? No, so this is not right. That is false. Now, we need to replace midsegment of a trapezoid with a proper term. What is a segment called that connects any two non-consecutive vertices? So let me show you what I mean by that. This picture was to help you realize that it's false. Now I'll draw something on that picture to help you realize what the actual answer is. So a non-consecutive vertice would be, and you should know this because we've talked about this many a time, that it connects one corner to not the next corner. That would be the consecutive vertice. The non-consecutive would be across like that. What's that thing called? A what? It's a diagonal. That's the correct term. All right, so a diagonal is a segment that connects any two non-consecutive vertices. I know my picture's not pretty, but I just had to freehand it. Number 3, the diagonals of a rhombus are perpendicular. True or false? Absolutely. That was the first one we talked about that had diagonals that were perpendicular. Okay, and you know what that means. A diamond, these are perpendicular. Don't make it look like a kite. You don't have to draw that. I was just reminding you what it looks like. A rectangle is not always a parallelogram. Okay, so let me, in case you're not sure, you have the quadrilaterals. You have, from the quadrilaterals, the first thing we talked about was the parallelogram. Then the parallelograms got more specific, and one of them was a rectangle, and the other was a rhombus. And then we got the most specific, I don't want that looking like a kite, excuse me, and we said one was both a rectangle and a rhombus, and that was called a square. Okay, now I just drew the hierarchy. Is a rectangle is not always a parallelogram. That's so false because a rectangle is always a parallelogram. Thank you very much. All right. Got it? Anything under here is a parallelogram because that's a parallelogram right there. All right, then off to the side, we talked about things that were called like trapezoids. Isosceles trapezoids. You don't have to draw this by any means. And the one other thing was the kite. Okay, so that should always be true. A rectangle, ooh, that should be plural. A rectangle that is also a rhombus is a kite. So you're telling me a kite is a rectangle and it's also a rhombus? Are there any right angles in a kite? No. All right, the kite word's wrong. This is false. A rectangle that is also a rhombus, a rectangle has right angles. A rectangle has diagonals that are congruent. That's it. A rhombus has 4 congruent sides, and a rhombus has diagonals that are perpendicular and angles and diagonals that bisect opposite angles. Rectangle and a rhombus is the special square. It would have to be a square, not a kite. Find the sum of the measures of the interior angles of each regular convex polygon. Regular implying all those angles and measures are the same. Then find the measure of one interior angle. Okay, so we want to first find the sum, then we want to find one angle measure. So you're going to have two answers, and this is kind of how I had set it up on that one quiz. And then some people, I don't know what happened. All right, the sum of the interior angles of any polygon is given by the formula. The sum is equal to 180 times the number of sides minus 2, which we developed together on the first day of talking about them. A decagon has the number of sides of 10. You are plugging in this formula. So what you're going to need to calculate is 10 minus 2, which is 8, 180 times 10 minus 2. So that's going to be 180 times 8, and you should get 1,440 degrees. That's the sum of all the angles. Next, if you want to know how big one angle is, then you're going to take the 1440 and divide by 10, and that's 144 degrees. Okay, got it? All right, go for it. Do number 7. Make sure you're going to get your own answer right, not just have my answer. Yeah, everybody in here should have a calculator open right now. I can't stress enough that almost every student will improve if they're making the calculations when we are making them in class together. Just sitting there and waiting for someone else to do it does not make you learn. Okay. At least for number 7, you should probably be done by now. So you should have 2,340 degrees for the sum of the angles. And then when you divided by 15, you should have gotten 156 degrees. Yes? Any problems with that? Okay, get your heptagon done. And don't round the angle, only go to the nearest tenth. Okay. The heptagon, how many sides? All right, good. So 180 times 5 is what we'll end up calculating. All right, should have already gotten it, 900 degrees. And then that weird angle, each angle, April, come on, 900 divided by 7. 128 point, and what should you round that to if I said the 10th place? Thank you. All right, so 128.6 degrees. Okay, let's start off this chapter, this unit, this chapter 6, with a good grade, our beginning of the semester, so you don't have to go to summer school. We don't want that. Find the sum of the measures of the exterior angles. Got to be careful when you're reading. The sum of the exteriors is not the same as the last problem. How much do the exterior angles add up for every single polygon we looked at? 360, all polygons that are, and if they're regular, they're each a certain amount. So 360 is the answer for the sum for every part, every one of these 3 questions. Always. Now, find one angle. Each, if it's regular, meaning all angles the same, find the measure of each. So we're going to take dodecagon, has the number of sides of 12, to 360 divided by 12. You get 30 degrees for number 9. Okay, find the other 2, please. I know some of you are good in doing the mental math. That's just more power to you. $360 divided by 18 should be 20 degrees. And the last one? Okay, how many sides does the hexagon have? You got to know that. And it's in your ISN, though. Divide by 6, 60 degrees. I heard 60. Good job. Okay, the measure of an interior angle is given. So this is an interior angle. If that's an interior angle, how big is the exterior angle? It's asking us to find the number of sides of the polygon. And the way you find the number of sides of the polygon is you take 360 and divide it by the measure of one exterior angle. And that'll give you n, the number of sides. So, first you want to find, well, what's the relationship between an interior angle and an exterior angle of a polygon? Just think about this. Say this is 120. What's this going to be? Because they are supplementary or a linear pair. All right, so 180 minus 135 is your first step. If you haven't figured that out yet. Okay, that would be 45 degrees. Now you say, okay, 360 divided by 45, and that'll tell you how big each angle, how many sides it has. And that's going to be 8. Okay, 8 sides. So, second one, if the interior is 166.15, the exterior is, do it. That's a weird amount, 13.85. Then take your 360 and divide it by your 13.85. Okay, and the number of sides would be, and you get decimals, so what are you going to round that to? If a polygon can't have partial sides, so it would round to, you get 25.99, so 26 sides. Okay, and that's okay, guys, because these were rounded also. The 26-sided figure has some strange measurements on its angles. I could show you. Oh. So if you did 24 times 180, that would give you the sum of the interior angles of a 26-sided polygon. You don't have to do this. I'm just showing you something. If you divided that by 26 angles, those angles measure 166. So basically, they dropped all that off when they were writing the worksheet because they had to. They couldn't write all of these decimals. So, that would have been awkward. But anyway, that's my point. These have already been rounded. That's why you didn't get exactly 26 sides. All right, what's the exterior angle for a 160-degree interior? Quick in your head, I hope. It would be 20 degrees. Take 360 divided by 20. You should be getting 18 sides. Okay. Anybody still need this? Thank you. Okay. Use ABCD to find each measure. All right. Now, this is just a parallelogram. You should know some things immediately about it. The opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Okay, let's see what we need. Measure of angle ADC. A to B to C would be this angle right here. And that's not going to be 115 because this one is 115. So these are supplementary. So 180 minus 115. And you already heard you, Priscilla, what were you going to say? 65 degrees. You got it. Side AD is opposite side BC, and they are congruent. So AD is 18. And what's AB? Yep, 12. Opposite sides are congruent. Next, it asks for angle, the measure of angle BCD. BCD. Oh, I already put it on there just for the heck of it. It's 115. Okay, now, I got to be honest with you. These questions are the most basic questions on the test. These need to be your easy ones, okay? All right, given that 19 through 21 are parallelograms, find the value of each variable by writing an equation and showing all work. Okay, this is a parallelogram. Tell me an equation, please, someone, that I can use to find x. Need some. All right, next time I'm going to ask someone else. So, Great. These opposite sides are congruent, so she set those two equal, and I like that you started out with the 3x minus 6 just because people like their x, larger amount of x on the left. So subtract x from both sides. 2 times x minus 6 is 4. And then you would add 6. 2 times x is 10, and then you would divide by 2. And hopefully if x is 5. Okay, now I need an equation to solve for y. There's a little extra information in this problem. I need to find y. Chloe? Very nice, yes. 5y equals 60. Okay, and just in case you were thinking it was 55, this is y, it's 60, that there 5y equals 60. There's your big N, and parallel lines implies alternate interior angles are congruent. So 5y equals 60. Divide both sides by 5, and you get y is 12. All right, with that in mind, have a look at number 20, please. I want someone else to give me a way to solve for x in number 20. All right, Brianna. That's it. Perfect. All right, 2x plus 41 equals 115. Okay, that's how you will solve for x, because opposite angles in a parallelogram are congruent. What? That's a 4. Get 74. 2x equals 74, and x is 37. All of you calculators out there. All right. Now, can somebody new give me an equation to solve for y? Dakasha? What, honey? Tell me what you want me to write. There you go. Good job. All right. That's it. Opposite sides of a parallelogram are congruent. Okay. So let's get our y's on one side by subtract 2y from both sides. Did you already get it, Bryson? I always do that to you. Got it in my head. Say Bryson. Oh, what am I doing? Can I do that? Oh my gosh. Crazy lady. Did I write everything right? Okay, so I gotta subtract 13. Did you guys get 6? All right. My pen's doing crazy things. It didn't write the y, though. That was me. Okay. Let's hit number 21. I need an equation, and I need to know why you're writing that equation. All right, Bryce. Sorry. If you're adding those, what would they add up to? But they're not angles, sweetie. Okay, so think about, okay, let me give you a hint. What do these do? There, you said it. They, give me the word again, the diagonals bisect each other. All right, you just told me the reason why I'm wanting this equation. Diagonals bisect each other. Okay, so what are you actually going to tell me to write now? You got it. 14x minus 34 equals 12x minus 8. You got it. All right, better? Do you understand the difference? You're good. Okay, great. Thank you. All right, so just do your algebra, subtract 12x. Oh, here's a real common mistake, guys, is to not bring down minus 8. Common mistake. I bet somebody did that in here. Bring down the minus 8. All right, then add 34. What we got? 2 times x is 26. And now divide by 2, and you should be getting 13. All right, let's check out number 22 now. Does anybody still need this? All right, 22. Oh, this isn't a parallelogram. I don't know why this directions came back up here. This is not a parallelogram. What can you do then if it's not a parallelogram? Kenny? Add them all up, okay? And then what? What's it going to equal? Okay, how'd you know it was 360? Because you've done it so many times, you remember? No, I'm just kidding. It is. I mean, that's really, I think a lot of you would be at that point, because how many quadrilaterals did we do? 180 times 4 minus 2 is 180 times 2, and yes, a lot of you have memorized that the angles of a four-sided figure add up to 360. So good job. All right, what do your x's add up to, please? And then your digits, your integers. 15 and 16, that's 31, and then you got to subtract 1. So that's positive 30 equals 360. Total is 360. All right, you guys can finish that off. When you divide by 11, what will you get? And I didn't say to find all the angles, I don't think. Did your paper tell you to find all the angles? No? All right, we're good. What was all that about? I don't know. Oh, were you? I get it. Doing it in your head, thought it was 33. Now, a little FYI, if you are trying to find this in your ISN and justify, that's 6.3, proving a parallelogram. Is that sufficient evidence to say for sure that this figure is a parallelogram? If you are not sure, oh, okay, what do these markings, what can we interpret has happened by the markings? And what are these things? Diagonals. Diagonals bisect each other. Does that mean you have a parallelogram? Just because they cut each other in half? I'm trying to trick you. It does. Okay, I was saying it in a way that would mislead you. All right, so I don't mean to do that, except that I want you to be confident in that, yes, that's one of those properties on that page. If you look at your ISN, it's on the page that says it's for 6.3 proving a parallelogram. So don't forget where to look, all right? So this is a definite yes, and you would need to tell me why. That's because a quad, and I'm not going to make you write the whole thing out, but if a quadrilateral has diagonals that bisect each other, then it has to be a parallelogram. So you need to write at least if diagonals bisect each other. Yes, if diagonals bisect each other. Oops, I wrote dissect. Oh, my Lord. Bisect. Oh, my technology. Okay, if the diagonals bisect each other, then it's a parallelogram. And you can just draw those symbol things if you want. 24 is probably the trickiest one of the provings. Yes, and that's if one pair of sides are both parallel and congruent, then it's a parallelogram. If one pair, opposite sides, are parallel and congruent, then you get a parallelogram. Then it must be one. Okay, 25. Does this need to be a parallelogram? Are the sides across from one another the same marking? So that means opposite sides aren't congruent. So this would be no way. So no, opposite sides are not congruent. And this one's extra. It's not on your paper. So I'm thinking, hint, hint, maybe on the test. Would this have to be a parallelogram? Yeah, because opposite angles are congruent, then if opposite angles are congruent, then it's a parallelogram. You don't have that one, I know. That's why it says extra. Oh, sure. Quadrilateral ABCD is a rectangle. If AG is 6K plus 44 and DG is 8K plus 16, find K. Oh my gosh, look at all that. All right, you need to go look at your picture. What's AG? AG is here, and DG, oh, that's over here. What could I say? Well, it's a rectangle. What do I know about a rectangle? What you need to know about a rectangle is its diagonals are congruent. So that segment is congruent to that one, and that one, and that one. So if AG is 6K plus 44 and DG is 8K plus 16, they're equal. Okay, subtract 6K from both sides. 2 times K plus 16 is 44. And do the rest of the algebra. $28. X is 14. Now, what did we just use to know they're equal? Two properties of the diagonals, or special quadrilaterals. Diagonals of a rectangle are, okay, diagonals are congruent, and that is for just a rectangle. Well, at least not a parallelogram or a rhombus. All right, the other was we used diagonals are congruent and that the diagonals do what? Bisect each other, all right. Ooh, crazy. It might have went a little haywire there at the end of the word each. Okay, EACH. I think we got it. Two properties we listed. Right? Please remember, you're not going to have forever to take the test. You should know a lot of this stuff, not have to be just looking it up constantly in your ISN. All right, find the measure of angle SQP. SQP. It's right here. How do you tell where an angle measure is? Where that angle is that you're talking about? Okay, the middle letter, and then it has to be between the S and P, so the angle is here. Okay, some people are having still trouble knowing where the angles are. If this is a square, how big's that angle got to be? 45. Yay, I heard it. All the corners are right angles. The diagonals are congruent. The diagonals bisect opposite angles. So those are all 45 all over the place. Okay, find the measure of F. There's a couple ways you can think about this problem. One of them is consecutive angles are supplementary. So all this stuff added up is 180. The other way to think about it is if you have parallel lines, alternate interior angles are congruent, and that's E's up there got to be 41. But they only asked me for F, so whatever, just figure out F. The angles add up to 180 no matter what I do. So F plus 41 plus 79 equals 180. Is that 120? Yeah. Subtract 120, we should get F is 60 degrees. Okay. 29. Okay, got a rectangle. Pay attention to what they're telling you it is. Bless you. If these questions are separate from one another, so do not confuse what they're telling you in 29 with what they're telling you in 30. You have to kind of start over, all right? So if FEG, this angle right here is 57, there are other angles that are 57 in that picture. But it's asking you for GEH, which is right next to it. What kind of corners does a rectangle have? What are the angle measures in the whole corner? All right, 90. So all you got to do is 90 minus 57. So angle GEH looks like it would be bigger than that, but it's only by what they're telling us. 33. Okay. Now to start the problem and process totally over again. So it's almost like you got to erase that. You don't have to. I'm just trying to explain. So if you already wrote on it, don't worry about erasing it. Just realize that that has nothing to do with what I'm about to do. So HGE, that would be down here, and it's saying that's 13. These really should have degrees on them. Okay, find the measure of angle FGE. So this problem is exactly the same as the last one, just different numbers. We need to figure out that the corner is 90, and we need to do 90 minus 13. So they totally changed the numbers up on us. And that's going to be 77 degrees. That looks a little more to scale, but not quite. All right, nothing to scale here. I'm going to ignore that now for a moment and get on with the next one. It says FK, which is right here, is 32. Find EG. Oh, well, I know the diagonals of a rectangle. You should know that they bisect, the diagonals bisect each other, and they are congruent. So how big is that diagonal? EG is not 32, but 64, 2 pieces. All right, and the measure of angle HEF. Oh, how big is HEF? 90. What's EFG? 90. Oh, 90 plus 90. Okay. It might be a good plan for you to work some on the rest of this. We will go over tomorrow. And we're going to mess around with the properties on the property wall back there. And we will answer other questions on other worksheets as well.